G'day. The other day I did a video on fixing up tangs on Morse taper drills, and today I thought I'd actually talk a little bit about this bit, in particular sharpening them. Now, I guess one of the first questions is, how do you know they're blunt? Well, apart from not cutting very well, and that could be not only because they're blunt, but a couple of other reasons. You can feel it. If you've got a sharp drill, you can actually feel a bit of an edge on there. If you've got a blunt one, it certainly doesn't have that sharpness to it, and I'll flash up a couple of photos in a moment which hopefully will show how that tip just gets, or that edge just gets rounded off a little bit. But I'll show you how to hand sharpen drills, which is a handy skill to have even if you don't do it very much, or you've got a sharpening machine, because at least you've got a basic idea of what's involved. And also talk a little bit about some of the differences in drills. This is a Darrex M5 drill sharpener. Sadly, they don't make them anymore. This one probably dates from, well, I think they stopped making them about 2005, I'm not quite sure, but they're still a good machine. They're the precursor to things like drill doctors and all that sort of stuff. The reason I like this is that because of the range of drills I can sharpen on it, I can go up to about 1 1/8", which is what, 28mm on this one. If I wanted to get a drill doctor with that sort of range, I'd have to get 2 of them, or get a very expensive or far more expensive industrial machine. So this does me fine. I've got a few spare parts stashed around the place for it, so I think it'll probably see me out. Anyway, the reason we're here is that I wanted to show you the action of this. This is a drill bit which has been sharpened, and you can see how the edge there drops away. Okay, now if you just put a drill on a wheel and turn it in a conical fashion, you won't get that relief, and that's what helps you drill. Now, when you look at what the Darrex does here, there's a cam on here. Okay, so what it's doing is as it's grinding, right? If you can imagine that edge is in contact with the wheel spinning, all that sort of stuff. As it's grinding, it's actually kicking the drill holder out, right? And that's actually producing that sort of relief on there. If I take that out of there, you can just see that there's a little bit of dropping away of that, and that's what you want. In fact, this drill was sharpened by hand. I've put on the Darrex, and you can see that it's the edges that have been touched up, so there's a bit more relief on there than this will put on there. So when we're grinding on our bench grinder, we want to have a similar sort of motion. So we'll come in and we touch on the wheel, and then as we rotate it, swing that back end round, because if you put that there and just rotate it, you get a conical form which doesn't give you the relief. And that's one of the problems with particularly some of these cheaper bench grinders. They have a 188 degree groove in there, and the idea is you put your drill in there and off you go. Well, if you do that, you're going to have to push in as you rotate to get that relief in there. So as you saw, as I was rotating that, I was moving the tail end over, and that's given me relief there. Okay, that might be a little bit more than is really needed, but it's relief. And provided it's not, way down here where it weakens the point of the drill, that's not too bad. One of the key things with getting a drill to grind on size is to have the lengths of the cutting edges the same. Now, one way to check that is with a gauge like this, and so there you can see, right, one cutting edge is 5mm long. When I turn around, that one there's 5mm long, so this one should be able to cut reasonably well. If you think about that, the reason is if they're uneven and it's the point that's guiding things in, that everything is going to rotate around the point. So if the point's over here somewhere, you've got basically that corner swinging around there. This side won't cut much, this side will. And another way to tell a drill's well sharpened is that both flutes are cutting the same amount. Now, if you want to know where to get one of these things, this comes out of a book called The Engineer's Black Book. Importantly, it's the second edition. I'm told the third edition doesn't have this in it, but the second edition, if you can find one, has one of these, and it lives in the back cover like that. And it's also got some other interesting information about sharpening drills. So if we look here, there's various point geometry for different material types. And typically, the harder material, the flatter the point. There's the drill gauge and how to use that. And there's also a little bit about thin sheet metal down here, where you want a flatter point for sheet metal so that the edges of the what would you call those? The flutes are engaged before the point breaks through. Okay, but general purpose drill bit, 118 degrees. So a worthwhile resource. It's got lots of useful information in it, particularly if you can get the second edition with the sharpening grade. But there's things on carbides, there's things on thread, which I refer to quite a lot. There's abbreviations, all that sort of stuff. So they're not a sponsor, but certainly a resource worth having. This is an example of a poorly ground drill. You can see that angle there is pretty much flat. So I'm guessing that when this drill was being used, or someone was trying to use this drill, I haven't used it, it's just one of a bunch that I've got lying around the place, it wasn't cutting very well, and that's just because there's very little relief in there. In a modern drill, the web up the top here is relatively thin. Down the back end here it gets a bit thicker. So as you sharpen a drill, sometimes we do what's called, I think it's called web thinning. I just do it. I don't necessarily remember all the names, but you can see here how someone has come in with a wheel and just taken off the back of the flute there, and on the other side. You have to be balanced with doing this sort of stuff. Now the reason for that is that when a drill is going into a hole, the bit that's starting it is actually where those two surfaces meet, that chisel point there. Okay, and so that's basically scraping material out of the way. Once you get out a little bit, the flute can pick up and start actually cutting. Right, now that's one reason why you always should, if you can, use a pilot drill. And the ideal pilot drill size is something just a little bit over the width of that chisel point. Okay, any more than that and your drill is like to rattle around in the hole. So that's the importance of using a pilot drill, and it does lessen the drill force quite a bit. But that's one way of reducing the size of that chisel point, and that means you're getting less force. The other thing that's done with drills is to take a bit off the back. So if we compare it to this one here, that's just coming down. Here we've actually got greater relief, and that's just something that helps once again get that drill in there. You could probably salvage this drill if you did that. If you came along and put some relief on here, and there's a special name which once again eludes me, that would probably make that drill a lot better. Now that's just a matter of touching on the wheel as you rotate round, just to give you that little bit of relief. It doesn't need to be much, and it doesn't, you don't need to go to town on it with an enormous angle, but that will help you once again get that drill cutting nicely. This is what I call a W point drill, from the shape of it. But what it is a drill that's been ground so that there's a point in the middle and a couple of spurs. Now these are quite good for woodworking because it means that when you exit the wood, it's the spurs that are cutting first rather than a drill like this where it's going to tend to push the material away. Have a friend of mine, Don, told me that sheet metal workers use something similar, and I'll show you the grind for that in a minute. But this is basically the result, and I'm certainly not an expert in doing this, so please don't say is that as good as it gets, because well, I'm not all that good at doing this. But what's happened here is that using the corner of the wheel, I've got a point here which will locate in a centre punch quite happily, and I've got a couple of sort of flattish areas here, and that should probably be a bit more pronounced to give you that proper W. But the idea behind that is that locates in the centre punch, and this then drills into the sheet metal. And the reason is that the sheet metal being thin, it will grab really easily, and so a drill point like this where the angle is pretty much close to flat will not tend to jump around, all that sort of thing, as much as a standard point might want to do. Just to prove it does work, these two holes were drilled with my W point drill. And you can actually see on here, I didn't expect this to happen, but there's the little disc of material which the drill has picked up on. Now, you could drill these holes with a step bit like this, and that's fine, provided that you can live with a hole being the size that is. But if you want another size, you could be in strife. This one here is 13/32, and interesting enough, these holes are only 0.1 of a millimetre bigger than the drill. Another drill that might get you out of trouble one day is one of these. This is a masonry bit, and the useful bit about this is that's a carbide tip on there. Now when these things are supplied as a masonry bit, you've got a bit of back relief there, but you've also got some negative rate on the front, and for brick and stone where you're pounding away, that's fine. You don't want a delicate edge. However, if you sharpen one up, and you probably can't see it too well on this one, but if you can imagine, if you sharpen that up so you've got basically a point, for want of a better term, an edge on the front there. These are good for drilling hardened steel in a pinch. Okay, and in fact I've known tool rooms where that's what they do. If they need a small hole in a bit of hardened steel or a bit of tool steel, they'll use a masonry bit like this. They'll just grind it up and off they go, sort of thing. Drills vary in length. In fact, there's several things that drills vary in. Length is the main one. That's what we call a jobber drill bit. That's the sort of thing you get in pretty much any kit of drills you buy at a hardware shop. They're a general purpose drill. That's what they're designed for, and they'll quite happily drill holes in most softer materials, steel and all that sort of thing. Hard materials they don't do so well in. But there is another type of drill called a stub drill, or sometimes referred to as a screw length drill, I think it is. As you can see, these are both 8.5 millimeters. The stub drill is considerably shorter. Now what that means is when you're drilling a hole, because that's held in the chuck, there's a lot less flex there, and so your drill won't wobble around quite so much. You can get various coatings. The gold coloured ones are titanium nitride, sometimes called tin, and that's just a hard layer on the top which helps hold the edge. If you're wondering what happens when you sharpen those, the cutting edge is actually on the inside here, and so when you sharpen that, you take material off the outside, so even if you remove that coating, it's not going to affect the drill. So there you have it, a few bits and pieces on drill bits, drilling, sharpening drills, all that sort of thing. So hopefully that's of interest to people. Please spread the word, and we'll see you for the next one.